these images are real. This could happen in your home, in your neighborhood, if a nuclear bomb exploded. These images were recorded in 1955 in Nevada, at a time when we were still trying to understand nuclear energy and its consequences. The history of atomic energy dates back to a time when its potential was still unimaginable. In 1896, French physicist Henri Becquerel, while researching the fluorescence of uranium salts, accidentally discovered radioactivity. He observed that certain materials could emit invisible radiation without the need for an external energy source. This discovery marked the starting point for a series of investigations that, over time, would completely transform our understanding of matter and energy, laying the foundation for the development of nuclear power. In 1898, Marie Curie and her husband, Pierre Curie, discovered polonium and radium while investigating radioactivity in minerals such as pitchblende, a uranium-rich ore. Through a rigorous process of purification and analysis, they observed that pitchblende emitted radiation much more intense than could be explained solely by the presence of uranium. This led them to hypothesize that it must contain other unknown and highly radioactive elements. After years of work using chemical precipitation and fractional crystallization techniques, they managed to isolate polonium first, named by Marie Curie in honor of her homeland, Poland, and later radium, whose name derives from its intense radioactivity. This discovery was revolutionary, as it allowed for a better understanding of radioactivity and laid the groundwork for the development of nuclear energy and its applications in medicine, including the use of radiotherapy for cancer treatment. In 1905, Albert Einstein published his famous equation, EH-mc2, showing for the first time that mass and energy are related. This idea was fundamental to understanding how a small amount of matter could be transformed into a vast amount of energy, as occurs in nuclear reactions. But the key piece of the puzzle would arrive in 1938. Otto Hahn and Fritz Strassmann, two German scientists, discovered what would become known as nuclear fission. While conducting experiments with uranium bombarded by neutrons, Hahn and Strassmann observed that barium, a lighter element, appeared among the reaction products, contradicting the chemical theories of the time. That same year, Lise Meitner and Otto Frisch analyzed the results of Hahn and Strassmann's experiment and deduced that the uranium nucleus had split into two smaller fragments, releasing a large amount of energy in the process. This discovery not only revolutionized physics, but also initiated the quest to control this energy. Originally, the motivation was purely scientific, but during World War II, the context of scientific research changed dramatically, and many advances in nuclear physics were directed toward the development of nuclear weapons. In 1939, Einstein, along with physicist Leo Szilard, signed a letter addressed to President Franklin D. Roosevelt, warning that Nazi Germany might be developing nuclear weapons. This letter was key to the creation of the Manhattan Project, something Einstein later deeply regretted, as he was a pacifist. The Manhattan Project was a research and development program led by the United States during World War II to create the first atomic bomb. Initiated in 1942, it involved scientists from various countries, including key figures such as J. Robert Oppenheimer, Enrico Fermi, and Richard Feynman. The project's main sites were Los Alamos, New Mexico, Oak Ridge, Tennessee, and Hanford, Washington, where studies were conducted on nuclear fission and the production of plutonium and enriched uranium. On July 16, 1945, the first nuclear test was carried out in the New Mexico desert, known as Trinity, confirming the project's success. Shortly after, in August 1945, the United States dropped atomic bombs on Hiroshima and Nagasaki, leading to Japan's surrender and the end of the war. The bombs dropped on Hiroshima and Nagasaki were two nuclear attacks carried out by the United States in August 1945. During the final days of World War II, and so far, they are the only cases in which nuclear weapons have been used in combat. On August 6, 1945, an atomic bomb called Little Boy was dropped on Hiroshima using uranium-235 as nuclear material. The explosion instantly killed about 70,000 people and destroyed much of the city, with a total of approximately 140,000 deaths caused by the bomb and its after effects. 3 days later, on August 9th, a second bomb, Fat Man, was dropped on Nagasaki using plutonium-239. Although Nagasaki's mountainous geography limited the destruction, the bomb killed about 40,000 people immediately, and the total death toll reached 70,000. These attacks were authorized by US President Harry S. Truman, with the aim of forcing Japan's surrender and avoiding a ground invasion, which was expected to be extremely costly in human lives. After the bombings and the Soviet invasion of Manchuria, Japan announced its surrender on August 15, 1945, ending the war. The international community reacted with horror upon learning of the bomb's devastating impact. There was widespread condemnation of the massive destruction and civilian deaths, though the wartime context and Japan's reluctance to surrender quickly played a role in how many Western governments interpreted the action. Following World War II, the world was divided into two major blocs: the United States and its allies in the Western Bloc, and the Soviet Union and its allies in the Eastern Bloc. This ideological, political, and economic division led to the Cold War, a conflict without direct confrontations, but with constant tensions, espionage, propaganda, and a nuclear arms race. Both the United States and the Soviet Union embarked on a race to develop and test more powerful nuclear weapons, increasing international tensions. Each country feared the other would gain a strategic advantage. In 1954, the Nevada desert witnessed a series of nuclear tests that would mark a turning point in the history of atomic energy. What began as a military experiment quickly became a health and environmental issue. The nuclear tests were atmospheric, meaning the explosions released radiation directly into the air, spreading it over vast areas. Radiation traveled through the wind, affecting both soldiers and civilians near the test sites. One example of this series of tests was Operation Teapot, 1954-1955, where nuclear bombs were detonated to study their effects on terrain and nearby structures. Scientists and the military sought to understand how materials like concrete and steel reacted to a nuclear explosion. However, the side effects of these tests were devastating. Not only did unprotected soldiers suffer severe consequences, but radiation also affected nearby communities, leading to cancer and other radiation-related diseases years later. Even more shocking, civilians living more than 160 kilometers away from the test sites were also unknowingly exposed to radiation. For them, there were no warnings, and the consequences were fatal. The Nevada tests of 1954 left not only a physical mark, but also a legacy of fear and awareness about the dangers of nuclear radiation. Their impact eventually led to the signing of international treaties, such as the 1963 Partial Nuclear Test Ban Treaty, aimed at preventing further atmospheric nuclear detonations. With the discovery and expansion of atomic energy, many fears arose, from its massive destructive power with atomic bombs to the fear of the unknown regarding the effects of radioactivity. These fears not only dominated the scientific and political spheres, but also deeply influenced popular culture. In 1954, Japan released Godzilla, a film that reflected the collective fear of monsters created by nuclear explosions. Godzilla not only represented the horrors of radioactivity, but also the fear of what atomic bombs could unleash, something beyond what humanity could control. During the same period, other films like The Day the Earth Stood Still or Them featured mutant creatures or alien threats born from nuclear experiments. In these films, nuclear energy was not only the driving force of destruction, but also the source of uncontrollable catastrophes and irreversible changes. After the devastation of the war, a new idea emerged: using nuclear energy for peace. In 1954, the Soviet Union inaugurated the first nuclear power plant for electricity generation, and a few years later, the United States followed. The dream of clean and nearly limitless energy seemed possible, but, as always, reality is more complex. In the following decades, nuclear power plants spread worldwide, but so did their risks. In 1979, the 3 Mile Island accident in the United States made it clear that controlling atomic energy was not so simple. In 1986, the Chernobyl catastrophe in the Soviet Union revealed the devastating consequences of a failure in safety. Thousands of people were affected by the disaster, and the surrounding area remains uninhabitable to this day. More recently, the Fukushima disaster in 2011, caused by an earthquake and a tsunami, reignited fears about the safety of nuclear power plants. Nowadays, nuclear energy is perceived ambiguously, shaped by the evolution of its image from its beginnings to the present day. In a world increasingly concerned about climate change and the need to reduce carbon emissions, nuclear energy is seen by some as a promising solution to ensure a constant and clean energy source. It is considered a key alternative to fossil fuels, capable of generating large amounts of electricity without directly contributing to global warming. However, the fears associated with nuclear energy remain present. The Chernobyl and Fukushima disasters, though distant in time, are still vivid reminders of the inherent dangers of nuclear technology. Nuclear accidents, although rare, are perceived as catastrophes with global consequences, capable of causing irreparable damage to both human health and the environment. Additionally, the problem of radioactive waste remains an unresolved challenge, fueling doubts about the long-term viability of this energy source. In many countries, there is growing public opposition to the construction of new nuclear power plants, driven by concerns over safety and waste management. However, in other places, due to the pressure to reduce greenhouse gas emissions, nuclear energy remains an option in the energy transition. In some regions, nuclear technology is being reassessed with the development of safer and smaller reactors, SMRs, that promise to mitigate some of the historical risks. Thus, the perception of nuclear energy today is marked by a delicate balance between its potential to combat climate change and the risks associated with its use, generating an ongoing debate between the urgency to adopt clean energy and the caution prompted by past dangers. Atomic energy is, in essence, a contradiction. The potential to transform the world and improve life, but also the threat of unleashing chaos. A delicate balance between progress and danger, where the scales tip depending on the hands that decide to play with the atom, between the hope for a clean future and the risk of unleashing its fury, questioning whether humanity is truly ready to wield the power of a sun in its hands.